Hello everyone. In this video we're going to be solving a quintic system. Yes, it's a quintic system and it should give us a quintic equation, but unfortunately there's no quintic formula. Sometimes the video title says we don't use the quintic formula. There's a good reason, because it doesn't exist. Anyways, I'll be presenting two methods and let's start with the first one. So my first method is going to be direct substitution. I'm going to isolate y equals 1 minus x, and then I can just go ahead and substitute it, right? Can't I? That gives me x to the fifth plus 1 minus x to the fifth equals 31. Obviously, at this point, you can go ahead and guess and check, but we would like to solve this completely. Okay, let's go ahead and expand 1 minus x to the fifth power. That's going to give us something like this. Really weird. It's backwards, so if you want to do x minus 1 to the fifth and then subtract it, that's fine too. But anyways, this is 1 minus 5x plus 10x squared minus 10x cubed plus 5x to the fourth power minus x to the fifth power equals 31. And here's the critical part. X to the fifth cancels out, and this is no longer a quintic. I said quintic system, but it's actually not quintic, turns out. Okay, let's go ahead and put everything together. Start with the highest power, 5x to the fourth, and then we get minus 10x cubed plus 10x squared minus 5x. Now I have 1 minus 31. That's going to be a negative 30. And now notice that everything is divisible by 5. So why not divide? Let's do it. That's going to make our expression much easier to handle. It's going to make it monic, right? We talked about the monic like about 2 hours ago, I think, right? So this is going to be my equation after division by 5. And again, the rational root theorem comes into play, RRT. That's what I call it. The factors of 6 aren't that bad. There's quite not that many. Plus minus 1, plus minus 2, plus minus 3, plus minus 6. Not as bad as 24. Anyways, so what am I going to do with this? I'm going to check quickly 1 and negative 1. Those are easy to check. First of all, look at some of the coefficients, and then you can do evens versus odds. None of them give you a 0. So x does not equal 1, x does not equal negative 1. I know that. How about 2? If you set x equals 2, you get 2 to the fourth minus 2 times 2 cubed plus 2 times 2 squared minus 2 minus 6. This is 16 minus 16 plus 8 minus 2 minus 6. This is 8 minus 8. This is 0. This is 0. Everything is 0. Collapses, right? Nice. So x equals 2 is a solution. Great. When you get a solution, you can definitely go ahead and factor this by using that fact. So if x equals 2 is a solution, then x minus 2 is a factor by factor theorem. So we can go ahead and divide this by x minus 2. However you want to do it, no matter how you do it, you're going to end up with a linear and a cubic. Okay, to keep a long story short, let me go ahead and tell you what that looks like. So this expression can be written as x minus 2 multiplied by x cubed plus 2x plus 3 is equal to 0. X equals negative 1 is a solution. So x equals 1 didn't work, but x equals negative 1 is going to work. But you can see it here too. If you haven't seen it earlier, I haven't. I apologize for that, but that's okay, I guess. Look at this. The odd coefficients are 1 and 2. And the even one is only 3. So it's a lot easier to check 1 plus 2 is equal to 3. In other words, x equals negative 1 is a solution of the cubic. Make sense? Great. So I should be able to factor it that way. Let's go ahead and break this down by that. So I'm going to go ahead and add x squared, subtract x squared. Then obviously I have to follow, this is already balanced out, and then I have to add the 2x, but also complete with, I have to subtract something from it, so I could probably just write it like this. Okay, I need to follow up, so this is going to have x plus 1. In order for this to have x plus 1, I have to follow up with negative x, but I have 2x, so I have to add 3x, and then I'll finish up with the 3. Here you go. And then I can factor by grouping. This is x squared times x plus 1. This is minus x times x plus 1. And this is plus 3 times x plus 1. And that is equal to 0. And then from here, x plus 1 out, and we get x squared minus x plus 3 equals 0. From here, obviously, you get x equals -1, and we already had x equals 2 from here. Now we're getting 2 more solutions, but they are not real. So here's a summary of all the solutions. If you use the quadratic formula, you're going to get, along with x equals 2 and x equals -1, you're going to have x equals -b, which is 1, plus minus the square root of b squared minus 4ac, which is 1 minus 12. That's a -11. Square root of that is going to be square root of 11i, which is complex or imaginary, divided by 2. So we have 4 solutions to our quartic. Remember, it's not quintic, it's quartic. All right, let's continue with the second method, and we'll finish up. Second method, and I'll show you, I believe I made a graph, and I'll show you that at the end. Second method basically uses a really cool idea, and I think we used this idea before. It's amazing. Because of the symmetry, I can do the following. Notice that the x and y are interchangeable, right? I'm going to replace x and y with something. Notice we have their sum is 1. So can you find 2 numbers whose sum is 1? Obviously, there are so many ways to do it. You can do t and 1 minus t, but I'm going to do something cooler than that, and that is going to be 1/2 plus t and 1/2 minus t. Why am I doing it? Because I want to use conjugates, because of symmetry. Look at that. So now if you plug those in here, you're going to get 1/2 plus t to the 5th power plus 1/2 minus t to the 5th power equals 31. And guess what? Use the binomial theorem, a lot of things are going to cancel out. To keep a long story short, I'll give it to you. If you add these up and simplify, you're going to get something like this. 5z to the 4th plus 5z squared over 2 plus 1 over 16 equals 0. Multiply everything by 16. You're going to get 80z to the 4th. Oops, I switched to z for whatever reason. It's supposed to be a t. Okay, anyways. So in t terms, this is going to be 80 t to the 4th plus 40 t squared plus 1 is equal to 0. That's my equation after getting rid of all the fractions. And you can basically do the following. Call t squared something. How about z? And then from here you find the z values, and then by square rooting them, you find the t values. So you're going to end up with 3 z values, t values. T is equal to -3/2, t is equal to 1/2, and z, t. What is that little confusion about the tz thing? And t is equal to plus minus root 11i over 2. Now, these are not the answers, because remember, x is equal to 1/2 plus t. So if you put this together with that, you're going to get all the same values that we talked about. And here's the graph of these two functions. The quintic one is pretty interesting. I think it's an elliptic curve, isn't it? And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.